Saxon's Trig, lesson 116, is the region of interest. Now, we've been working on graphing, and the last time we did a rough sketch. In this lesson, we're going to do actual accurate sketches for the given equations. So in order to help us figure out where we should be graphing, they're giving us some extra information here to try to help, and it's called the region of interest. So in an equation, if you have 3x to the fourth minus 11x cubed plus 9x squared plus 13x minus 10 equals 0. This is the way the equation is given, but we're going to fix it so that our coefficient is 1 on the highest exponent value, not 3. So divide everything by 3, and this crosses off. This goes to 11/3. This would be a 3. This would be 13/3. This would be 10/3, and 0 divided by 3 is still 0. So which of those is the highest amount? So this one is like 3 2/3. That's more than this 3, but this one is 4 and something, so it overrides this one, and this one is 3 and something, so the 4 and something overrides it. The highest value then is the 13/3. Now the region of interest says find the absolute value of this one. So if it was negative, throw the negative out and ignore it, and then add a 1 to this, which if you make that a common denominator is 3/3. So 16/3 is your region of interest, or basically, what is that, 5 1/3. So what you're trying to say is that in the graph, all of your places where you cross the x-axis, any turn points that you may have, any flex point that might exist, all of those are going to fall within 1, 2, 3, 4, 5, and a smidge, and 1, 2, 3, 4, 5, and a smidge, and then the same 1, 2, 3, 4, 5, and the smidge, and then 1, 2, 3, 4, 5, and the smidge. So in this circle, which might look more like an ellipse, because I certainly did not, that's spaced way wider than those were, but it would be a circle if those were graphed on graph paper or spaced exactly correctly, evenly. Then all of those turns and so forth will fall within this circular window. Now, in example 1, it says to graph y equals x cubed minus 3x squared plus x plus 1. So I see already that my coefficient is 1. So to test my boundary, I wouldn't need to divide by anything. So these are my numbers. The highest one is the negative, or is the 3, basically, because 1, 1, 1, and 3. So 3 plus 1 is 4. So I know that my window is between 0 and 4 on the positive side of things. Or negative, actually, let's just say -4 to 4. There we go. That's my circular window there. So I'm going to choose numbers to test that are between -4 and 4. Now later I give you another shortcut which makes life a little easier, and it narrows down this circular window to more specific numbers. But if all we have is our circular region of interest, then we're going to plug in, and we can do synthetic division as the fast way to test numbers to see if their answer is coming out 0 or something else. So with synthetic division, I'm going to pull the coefficients 1, -3, 1, 1, and then I'm going to be testing a variety of things. So the easiest one to test is 1. So let me do that. Drop the 1. 1 times 1 is 1. That's -2. -1. -1, 0. Oh, when I plugged in 1, I got a 0. Okay, well, that was just kind of a fluky, lovely guess. So the other thing I know from looking at this equation is that it's positive. So overall, it should be going up. It can have up to 2 curves, and it's falling 3, 4, 1, 2, 3, 4. I'll go ahead and put a couple of these on here. All right, so when we plugged in 1, we got a 0, so we know we have a dot on the x-axis right there. That's not enough places for me to know how my curvature goes. So, however, oh, and I have options here. The book is going to continue to do synthetic divisions with other numbers, 2, -2, 3, 4, -4, and get a series of dots and then graph it. I know that when I find a 0 answer, I can factor it to find any other dots that I might have. And I might try that just as a quick thing. So putting this back into equation form would make it x, highest was 3, so 2 minus 2x minus 1 equals 0. If I split that into 1 and 1, ooh, maybe 1 and 1, and oh, no, it won't work. Okay, I just realized when I go to do my signs, this one has to be negative, so they would both have to be negative in order to get -2, and negative times negative is positive, so I can't factor it. So I cannot use that to help me find any other dots. That also tells me that I don't have another place that is a nice even number. It's going to be some sort of decimal if I cross the x-axis again. All right, so if I do continue with their synthetic division, I didn't leave myself enough space really. 1, -3, 1, and 1, and then let's test 2. So we'll drop the 1. 2 times 1 is 2, adds -1, -2. That's my 1 for here. 1 and -2 is -1. 2, that's -2. 1 and -2 makes -1. So I now know that when I plug in 2, I'm graphing a -1. All right, that's a huge help. They tested, all right, if you use their testings on the bottom of page 639, they plugged in -2 and got an answer of -21. Now, I don't want to graph that. I just know it's way down there. When they plugged in -1, it spit out an answer of -4. That's not too bad to graph. And then when we did the 1, we did the 2, they plugged in 3, they got an answer of 4. That's not too bad to graph. And with those, I would have enough to say, oh, yep, I've got 2 curves in here. And when I did that other -2, it was way down there. So this is definitely climbing up. And when I get to this point, am I going through it? Yes, because it was not part of a parenthesis that was squared. So I am going to come up just probably a little bit, and then I've got to drop down to this dot, and then I've got to very quickly get up to this one. So overall, I'm climbing. I've got 2 turns in it, and all of that is acceptable. And this other dot where I crossed the y-axis was not at an even spot. All of that fits what I know for the graphing. Okay, let's try example 2. Graph y equals x cubed plus 4x squared plus x minus 6. Again, my coefficient is 1, so the highest value is 6. 6 plus 1 is 7, so I know that I should be plugging in numbers between -7 to 7 as my region of interest. And again, they do synthetic division to test. I know that I can have up to 2 curves because the highest exponent value is 3. It's positive, so it should be heading up. And then let's test 2. All right, so our coefficients are 1, x cubed, x squared, plain x, no x, okay. 1 drops, 2 times 1 is 2, 6, 12, 13, 26, and that should be 20. Okay, so when I graph sorry, I should have already done those. Okay, so plugging in 2 got me 20. That's really high up there. So I probably don't want to test anything higher than a 2 unless it's dropping back down. So let's test a -2. So we have our 1, 4, 1, and -6. Drop our 1, -2, 2, -4, -3, +6. Oh, 0, that was a good guess. So -2 graphs 0. And I could at that point see if it would leave me any factorings. I'm gonna go with the assumption that it can't. Now, I also know that testing 0, like when I'm normally doing a graph, I wanna see what's happening at 0 because it's usually easy. But when I plug in 0 and I multiply, it's easier to just look at the equation because this is 0, 0, 0. Oh, okay, that basically gives me -6. 1, 2, 3, 4, 5, one more. -6, so 0, -6. I know that then I should be coming up somewhere. I might have bounced and then come down. So I don't feel like I have enough information to actually know for sure what's happening. So I'm going to test -3 to know what it's doing there. Drop the 1, -3, 1, -3, -2, +6, 0. So now I know 1, 2, 3. This is also a 0. Okay, so I'm glad I did that because that now tells me that if I'm coming up to this point, it's got to bounce somewhere in here, drop down to this one, and then skew back up. So I would technically then need to test if it wants a specific graph, not a sketch, to see exactly how high that would be. So now, unfortunately, I would have to test a -2.5 to see exactly what it's doing. 1, 4, 1, -6. So drop my 1, -2.5. I hate working with fractions, but you do what you have to do. And of course, on the calculator, that's going to be much faster. So that should be 1.5 times, so it's going to be -3.75, -2.75, multiplying with -2.5, positive 6.875. Put that together, and I have a slight 0.875 as the remainder there. So at -2.5, I am just barely above. I don't even get to the 1 because it's 0.8 something. So that now tells me that's a really tight curve in there. If you wish to test -4, and I think they did, yes, they did. And so when they tested -4, they got -10 as the remainder there. So that would have been far down. And since we already knew that the other one was pretty far down, we're going to estimate that we're climbing up here. This has to connect to here. And then we know that we're skewing up pretty quickly. But I really want to know where I am skewing up. So I feel like I need to test something else. So let's test the 1 and see what we get there. 1, 4, 1, -6. 1, 5, 5, 6, 6. Oh, 0. That's beautiful. So 1, 0. Now I know that it's skewing up really quickly. So now I feel much better that I have an accurate graph. Since this was another 0 that I found, I could have factored this one. So if I had taken this one to its equation when I first tested it, I would have, highest was x cubed. So x squared plus 2x minus 3 equals 0. And then if I had factored 2x and x, 3 and 1 makes the 3. Center one is positive, so the larger number must be positive. How do I go from 3 to 2? I'm minus 1, and positive times negative is negative. Oh, beautiful. So then I knew that I had another crossing dot at 1 and at negative 3. So if I had used my shortcut that I tried on the last problem and didn't work, if I had used it here, I could have jumped to the dots at negative 3 and 1 and saved myself doing those synthetic divisions. But whatever's working for you that gets you to the graph the quickest way, you know how to do the graph, and it doesn't break mathematical rules, you're good.